We have to calculate height of a satellite in an orbit of radius r, small r. We will consider Earth of mass m and radius r. We will consider it as a perfect sphere and a satellite of mass small m moving in an orbit of radius r from the center of Earth. That means its altitude or the height is h. We have to calculate what is the value of the h. We will calculate it from the time period and orbital velocity. We know that the time period is equal to distance divided by velocity. So distance traveled in one orbit is circumference of the circle with radius small r, so it is 2 pi r divided by orbital velocity v. Now the orbital velocity is equal to r root of g divided by r, where r is the radius of Earth, g is the acceleration due to gravity, r is the radius of the orbit. Putting the value of v here, we get t is equal to 2 pi r divided by r into root of r divided by, taking the r inside in the root, this r becomes r square and r square multiplied by r becomes r cube. So we have t is equal to 2 pi divided by r into root of r cube divided by g. Now squaring both sides, it gives us t square is equal 4 pi square divided by r square r cube divided by g. Simplifying it, it gives us t square r square g divided by 4 pi square is equal to r cube. Now we know that the radius of the orbit r is equal to the radius of the Earth plus the altitude. That means r is equal to r plus h. Putting r plus h value in place of r, we have r plus h whole cube is equal to t square r square g divided by 4 pi square. Now taking cube root both sides, we have r plus h is equal to t square r square g by 4 pi square whole 1 by 3. H is equal to t square r square g by 4 pi square whole 1 by 3 minus r. From the calculations of the time period, r being 6400 kilometers, g being 9.8 meters per second, we can get the value of the altitude or the height above the ground surface. Angular momentum of a satellite of mass small m that is orbiting around the Earth at an altitude of h, or from the center of Earth, the radius of the orbit is small r. We have to calculate what is the angular momentum of the satellite. We know that the angular momentum is equal to mvr, where m is the mass of the satellite, r is the radius of the orbit, and v is the orbital velocity. We know that the orbital velocity is equal to root of gm divided by r. So the angular momentum will be equal to m root of gm divided by r into r. Taking m and r inside the root, we get L is equal to root of gm m square into r square divided by r. R and square goes, so the angular momentum will be equal to gm m square into r whole 1 by 2. This is the angular momentum of the satellite. So here the angular momentum of the satellite depends upon the mass of Earth as well as the mass of the satellite, where the orbital velocity doesn't depend upon the mass of the satellite.